So over here, if the wall crawler overlaps with the right wall, we have a first check checks whether or not the wall crawler is actually stunned. If it is not stunned, then it's very easy. We just create another, or we cast a ray to the wall crawler, and we just make sure that we don't execute anything really. What it's basically doing is it moves from this wall to the other wall, and it essentially stays like that. But if it is true, then it becomes more interesting, because then we have to also take into account, okay, well, if it is stunned, have all the legs been destroyed? If the wall crawler is stunned but not all of its legs have been destroyed, then it becomes more interesting, because then we have to actually make sure that, or I'm sorry, I actually didn't explain that correctly. The first one, if the wall crawler is not stunned, then whatever is regulated in the original behavior, which is if it's jumping from this wall to this wall, it should rotate correctly, like this, so it lands on its legs. But if the wall crawler has been stunned, we need to create another, or we have to check whether or not all the legs have been destroyed. Now, most of the time, what this will do, most of the time, for the majority of the battle, of course, the wall crawler will probably be stunned, but not all of the legs have been destroyed. And what this provides is, we need to make, what this does is, we create a correct rotation. So if the wall crawler has been stunned, but not all of the legs have been destroyed, then this means that this is true, but not all of the legs have been destroyed, so that is false. Then what this essentially does is, it casts a ray to the wall crawler, we create an audio, or sound effect rather, for audible feedback, and then we set this boolean, and we set this boolean to wall crawler overlapped with right wall. And this is essential for the rest of the script that is executed over here. And this has everything to do with the rotations of the wall crawler. So there's an event tick right over here, and this event tick essentially asks on every single frame, has the wall crawler overlapped with this particular wall? If it has, then execute the following, but for safety reasons I create another check to make absolutely sure that even though if the wall crawler has been defeated or has overlapped with a particular area or wall, in this case the right wall, then we check whether or not the wall crawler is actually stunned. And if that is true, we create a rotation that is based on the original left orientation of the wall. So with the left orientation, I mean a rotation that is correct for the left wall. So that would be a rotation like this, where the wall crawler is correctly positioned. And what that does is, because we are overlapping with the right wall, then what that means is that the original rotation based on the left wall will be the same for if it has been stunned on the right wall. So if the wall crawler has been stunned, then rotate it in such a way where the legs are similar to that of the rotation when it was on the left wall. And the rotation has to be smooth. Obviously, we don't want a rotation that is instantaneous. That doesn't look right. So here I've collapsed this into a macro because otherwise this blueprint would be even bigger than it is currently. So I've collapsed this into a macro, and this is what is inside the macro. So we execute the node set actor rotation, and we target the wall crawler, which is done over here. There's an input and there's an input that goes essentially back to the main level blueprint. But from that actor we get its current rotation, so that means the current rotation of the wall crawler, which could be something like this, and we create an interpolation 2 or rotation interpolation 2 node. And what this does, it basically gives a smooth rotation of one rotation to the next, and because it's all based on event tick, then this becomes even smoother because it essentially updates the rotation every frame, which by the way we optimize later in the blueprint. So the rotation over here, there's a node called make transform, and there's a rotation that is inputted from here, which leads to the rotation that is based on, in this case, the left wall, which is a rotation or rotator variable type that I created for all of these 4 walls. So there's one for the right wall, the left wall, the top wall, and the bottom wall. And all of these have a different roll, pitch, and yaw based on the correct rotation of what it should be. So in this case, for the left wall, the rotation, or the roll rather, is minus 90, which makes sure that this is on, the wall crawler will be rotated in this manner. Whereas the right wall is a roll of positive 90, which, as you can see over here, rotation of roll positive 90 will make sure that it's like this. So what it's doing over here is it gets the current actor rotation, which could be something like this. It is the rotation of the target, which is the wall crawler, and then we make that transform. We return that transform based on the whatever it is that we plugged in over here, in this case right wall or left wall orientation. We plug this into the rotator interpolation 2 node, get world delta seconds, the interp speed, so which is essentially the interpolation speed. We return, which gives us a return value, and we plug it into the new rotation. Essentially what this does is it makes sure that if, for example, the wall crawler was in a rotation like this, and it would be stunned and it would hit the right wall, that it would smoothly transition over to the right rotation that we plugged in over here. And that is done for all of these walls currently. But then, of course, after the stun duration, which is in this case 8 seconds, obviously the stun or the wall crawler cannot stay in this position, because in that case, what it will do is it will begin to jump in this manner. So let's say that the wall crawler or the beam players or the players are over here, and the wall crawler has just been stunned, and he gets out of the stun or the stun duration. Then, if we didn't, obviously, then we do want to make sure that the rotation is correct again, because otherwise it will jump in this manner, which means that the players won't be able to actually hit the stun area, which is on the other side. So what we do is, after the stun duration, which is in this case 8 seconds, what we do is we smoothly change the rotation again to be essentially the correct position, and this is done over here. So if that condition is false of it actually being stunned, which is a boolean that is updated on every single well, not every single tick, but it is a value or a boolean that is updated. So if is stunned is no longer true, then it means that it's false, and then this node will make sure that we actually get the right rotation again, at which point the wall crawler will jump or rotate from the sort of stun rotation to its correct rotation. And then we play one more animation to sort of provide more feedback that the wall crawler is about to sort of flip itself from the incorrect rotation to the correct rotation. And all of that, this is all related to scripted events such as the doors and such, which is not really that's related to the wall crawler per se. And when we compile all of that and we put the wall crawler back to its original position, and we play the game, then this is what the actual boss battle is, which is what I showed at the beginning. But after all this and compiling all of these, both the source code and the blueprints, then this is what the actual this is what all of that code actually does. Over here it's jumping, it's based on the rotation or the position of the beam player. At this point I'm trying to stun it as a shield character. That's the random jump chance that we just had there. And now it's stunned. And what that means is I've used the shield, and now I can use the beam in order to hit the legs. You can see right now, after that stun duration, it will rotate itself back to the correct rotation. We do this again. We hit it. I didn't hit it with the shield that time. So we get close to it. We hit it. There's some audio cues that signify that we have actually hit it. We hit the legs with the beam. It's a bit laggy because I have a few windows open. And this is where it actually hit me. For demo purposes, I will cheat. I stun it again. Again, you have the controller vibration. Actually, let's close down this. Just having the blueprints open is kind of demanding for the game that you're currently playing, especially if the blueprints are quite large in that sense. Okay, this is much better. Right, so we have just stunned it. There's some audio cues. It's the beam player. We're trying to hit the you can see this is where the health system comes into play. Just stun it, and we weren't able to do so in time. Stun it again. After that there's a slow motion effect, and the wall crawler is considered to be defeated at this point. And that's what the wall crawler does. And after that these doors should open and the players can progress through the rest of the game again.